Well, hello everyone. Welcome back. This is Console Room 2026, and I'm Michael Zecca. I originally studied astrophysics in my younger days, although I've gone on to different careers since then, so I still have a passion for space. And you may have seen some of my science talks here at the convention before, but today I'll be talking about 50 years of Mars landers. And there have been a lot of missions to Mars over the last 6 decades, but we're not going to focus on the orbiters on this one. We're going to focus just on the ones that have made it to the surface of the next planet away from us after the sun. So here we go. So one thing that we have found with the Mars landers is that over the years there have been 21 missions that have tried to land something on Mars. About half by the United States, about half by the Soviets or Russians, with a few other groups having also tried landers. The Soviets and Russians, unfortunately, have had mostly failures, and the United States has had mostly successes. Now, the very first attempt to land an object on Mars actually happened in 1962, which is only a few years after the original Sputnik probe was launched into orbit. So we weren't even very far into manned spaceflight at this point. And the Soviets sent Mars 2MV3 number 1, also known as Sputnik 24. Unfortunately, it had a rocket problem even before it got out of Earth's orbit and failed and came crashing back down. Fast forward about a decade, in 1971, the Soviets sent two probes, Mars 2 and Mars 3, to try to land on Mars. Mars 2 actually did reach the surface of Mars, but the landing system itself failed, and so the spacecraft was mangled on impact. A few months later, Mars 3 actually made a soft landing in Serenum Terra, which is kind of in the southern part of Mars, basically roughly how far south Australia would be. And unfortunately, while it did land successfully, its transmitter failed less than 2 minutes after it landed. It started to transmit an image and then cut off 20 seconds in. 3 years later, there was another attempt, Mars 6. Contact was lost again during the descent, just as the retro rockets were due to fire. And so it could be that the rockets didn't fire and it smashed into Mars. And Mars 7, around the same time, also had problems with the atmospheric insertion due to a malfunction, so it ended up missing the planet and going into a heliocentric orbit rather than entering the atmosphere. It's kind of a rocket trajectory issue. So, one quick thing here. This is that first image that was being transmitted by Mars 3 in December of 1971. So this would have been the first image from the planet Mars, from its surface, but it's not a complete image. And one thing that plagued the Mars 2 and 3 missions is that there were some pretty raging planet-wide dust storms going on at the time that they arrived at Mars. Actually delayed their landings because they were trying to wait for these dust storms to settle down, and it was something that had not really been observed before. So this was really the first observation of the big dust storms that we now know are a big part of Mars, and these dust storms will come back to be a problem for some of our future landers. All right, well, now let's jump forward to 1976, 60 years ago. And this is Viking 1, which was later renamed the Thomas Much Memorial Station. Thomas Much was like one of the engineers or scientists that developed this probe. This was the first successful Mars lander, and this was the first mission the U.S. had sent to the Martian surface. So we got there on the first try. And Viking 1 landed in Chryse, Planitia, which is kind of in the tropics, a little bit north of the equator. If you know Mars's geography at all, you'll know that the northern part of Mars, a lot of it we think was an ocean at one time, many millions of years ago. And so we were trying to land Viking in one of those clear plains that would be kind of near the shores of this ocean. And part of the reason for that I'll get into in a moment. The original plan was to land this on July 4th, 1976, the bicentennial of the United States. And unfortunately, the first landing site turned out to be a bit rockier than we expected. So they delayed deploying the lander from the orbiting spacecraft for about 2 weeks and to an alternate site that they found that was a bit smoother. And so they instead chose July 20th to celebrate the 7th anniversary of the Apollo 11 landing on the moon. And the Viking 1 spacecraft actually operated for a full 6 years and would have continued to do so, except it basically got a bad firmware update, which corrupted the software on the spacecraft and it ceased to work. One of the problems with when you're doing a software upgrade from 100 million miles away. And real quick, this is a quick map of Mars with the locations of many of these spacecraft I'm talking about in this mission. So you can see Viking 1 a little bit north of the equator in kind of a possible ocean shore type area. And the Sojourner rover that we'll talk about later was in a similar area of Mars, a few hundred miles away. And you can see there are some that were in, a lot of these have been closer to the equator. Mars is a very cold planet. And so by being closer to the equator, we can stick with temperatures that are maybe a little bit closer to Alaska or Siberia rather than the extremes of the poles. There are some real challenges with keeping these landers and rovers awake because batteries will freeze in those kind of temperatures. And so I just want to give you kind of an idea of where everything went, and that over time we have started to get a little more extensive into, getting further north or further south. All right, well, moving on. This was the first image that came in from Viking 1 after it landed. It shows a fairly smooth plain with some smaller rocks. No vegetation to be seen. You can see sunlight in the distance. The sun is not as bright as it is here on Earth. You're about twice as far away from the sun on Mars as you are from the Earth, which means the brightness of the sun is down to about a quarter of what we would experience on Earth. So the bright sunny days kind of look like an overcast day here on Earth, but you do get plenty of sun. All right. Well, the very next day, the color camera tested its capability, and we got a good look at the surface. And you see a lot of that classic red Martian dust coating everything. But there are rocks amidst there, and you can see that they themselves are not red. They just have a coating of dust on them. Viking 2 was launched around the same time, intended to land around the same time. It has been renamed the Gerald Soffen Memorial Station, again after one of the men that worked on the spacecraft. It landed in Utopia, Planitia, which is a bit further north and kind of in the middle of that, what we think was an ocean. The latitude is similar to Minneapolis, actually, for where Viking 2 landed. And this landed on the 3rd of September, 1976, and actually operated for a little under 4 years because the batteries did eventually fail in that colder northern climate. And this is Viking 2's first image. You got a nice panoramic view there, and you can see there's a little more curve to the landing site, and some of the rocks are a little bit larger, but still kind of a smoother plane than some places we'll see later on. And this picture is not from the next day, but actually from a few years on. One of the advantages of being a little further north is Viking 2 actually woke up one morning to frost on the soil. So that was definitely evidence that liquid water and then frozen water can still exist on Mars. It's a fairly dry world, but there is water if you can find it. You may have seen pictures of the Martian polar caps or even looked at them through a telescope. Those polar caps are primarily made of dry ice or frozen carbon dioxide being the main gas in the Martian atmosphere. One nice thing about it being a carbon dioxide atmosphere is that it does produce a nice greenhouse effect. The surface of Mars would actually be colder without it, but it's still a pretty cold place, and as you can see, we actually do get frost on Mars. So, talk about some of the successes and failures with Viking. Those 2 missions lasted a pretty good long time. The landing rocket design was designed to minimize disturbing the surface material as the spacecraft landed. They really wanted the soil around the spacecraft to be as pristine as possible because they were going to do some testing of the soil, and they didn't want the spacecraft to really disturb what was there. And that worked. There were a variety of gas chromatographs and spectrometers and stuff on board, and they had a nice robotic arm that could reach out and scoop up a sample of soil and bring it into a chamber inside the spacecraft where they could run a variety of chemical tests. And what they were looking for was any signs of microbial life. We really want to know, is there life on Mars? And that search was fairly inconclusive. Some of the tests were very negative, but there was also one that was positive, which was confusing. If all these others are negative, why is this one positive? That has been revisited in recent years, and we're starting to wonder if we actually did discover some sort of microbial life, but the jury's still out. Viking 1 was able to provide another successful test of Einstein's theory of general relativity, and this is with time measurements, transmitting back to Earth and measuring time and seeing how things were slightly out of sorts because of relativity. Viking 2 had a slight problem in that just before it was going to land, one of its retro rockets fired again when it shouldn't have. Not for very long, but just enough that it kind of skipped to another place to land. And when it did, one of the legs came down, propped on a rock. So the whole spacecraft was tilted slightly. Wasn't catastrophic, fortunately, but that's why some of the pictures look a little bit tilted on that one. And as we mentioned before, Viking 2 was able to capture on more than one occasion frost in the morning in the winter on Mars. Both spacecraft carried a seismometer that was supposed to deploy, reach out and then set on the soil so that you could measure any earthquake or Mars quakes or any sort of seismic activity in the surface of Mars. Unfortunately, those seismometers did not work. So it'll be several years before an actual seismometer was deployed to Mars and we could study that sort of thing. All right, moving on. Jump forward about a decade and the Soviets were back in the game with three more spacecraft heading to Mars. Actually, two more spacecraft heading to Mars. First was the Phobos 1, which is a new Soviet spacecraft design. All their previous attempts to put a lander on Mars were basically reusing repurposed Venera spacecraft, which were what they successfully landed on the planet Venus. Those are very large, heavy spacecraft. The newer Phobos 1 design was a bit sleeker. This was launched in July of 1988, and the plan was for an orbiter to insert itself around Mars, make some passes at Phobos and Deimos, the two moons of Mars, and then deploy a lander to land on Deimos. Unfortunately, there was a software update en route to Mars that deactivated the attitude thrusters so they could no longer steer the spacecraft, and within a few days that caused the mission to fail. So unfortunately, Phobos 1 never even got to Mars. On the other hand, Phobos 2, which was launched a few days later, actually did arrive in Mars orbit on January 29th of 89. And the intent in this case was to land the lander on Phobos. And so over the next 2 months, the Phobos 2 orbiter was working through various passes at the moons and adjusting its orbit so that it could successfully deploy that Phobos lander. And it got 37 images of Phobos along the way. Got some lovely ones up there in the upper left, and that one in the lower left is the last image it took of Phobos from just a few hundred kilometers away, just before contact was lost. Unfortunately, we were actually at the point where they were getting ready to deploy the lander to Phobos when they lost contact, and we don't know why. And I'm old enough to have been around when this happened. I remembered that the tabloids were speculating that it was aliens and blah, blah, blah. They didn't want us to see what they had hidden there. And no, that's not likely. But one thing we do know about, some of the asteroids and dwarf planets in the outer solar system is many of them have small moons themselves. So one wonders, Phobos looking like a captured asteroid, does it have a smaller companion that we've never seen? Or even just little hunks of rock flying around it? Perhaps the spacecraft came in contact with one of those. We don't know. But for whatever reason, Phobos 2 was lost very close to Phobos. All right, well, and again, then we went another little gap, but in 1996, the Russians, now no longer the Soviet Union, planned another ambitious mission to Mars. Originally, it started as 2. So you see with Viking and Phobos, sending a pair of missions was kind of good because you could go to different locations and you could kind of guarantee some redundancy in case one of them failed. Unfortunately, because of the fall of the Soviet Union, the mission went through several cutbacks and delays, but eventually it was launched in late 1996. Unfortunately, the 4th rocket stage failed on its second burn, and so it did not fully leave Earth's atmosphere and came crashing down to Earth not long after. And one thing to understand with some of these missions is, especially to the outer solar system, we often will have a small nuclear reactor on board that has a small plutonium core that slowly decays across the course of the mission and provides power. And there was a lot of concern about what would happen to that plutonium when it re-entered the atmosphere, and this ended up impacting future United States missions. There was a lot of concern about them launching the Cassini mission to Saturn not long after with one of these plutonium cores on board. Oh no, what happens if it comes crashing to Earth like Mars 96? So, pretty crazy times. All right, well, now we get to one of our great successes. In late 1996, the Mars Pathfinder mission launched to Mars. Took about 6 months to get there and did land on July 4th, 1997 in Ares Vallis in Chrysoplanitia. So it's landing again in that kind of ocean shore area, a few hundred kilometers from Viking 1. And the mission ended about 4 or 5 months later in September of 1997. The lander, after landing, was renamed the Carl Sagan Memorial Station, and the rover was named the Sojourner rover after Sojourner Truth, one of the pioneers of civil rights. And this was the first rover that could actually leave the lander and travel around on the surface of Mars. Pretty cool concept. Another thing, that was really cool about this mission was the way the lander came down. Rather than just using a parachute and retro rockets like previous missions, since this was a small, lightweight spacecraft, they built it as a triangular pyramid. For those of you that play Dungeons and Dragons, it's the same shape as a D4 die. And it came down with a parachute, and then as it approached the surface, a bunch of automobile airbags inflated around it so it could just hit the surface and bounce around a bit. And then once it came to a stop, those airbags could be deflated. Now, you got a 1 in 4 chance of which side you land on, but the motors on the doors were strong enough that whichever side it landed on, it could flip the lander open in the correct orientation, or at least that was the hope. So this was a test of a new landing system. Just successfully landing would be a huge success with this mission. And as you can see, the rover was basically strapped down to one of the 3 doors. As it so happens, we got lucky, and the bottom of the lander was the part that landed on the bottom. So we didn't have to have one of the doors flip the whole spacecraft open. It was already on its butt, essentially, and then the flaps opened, and within a day or two, they were able to get the rover to start heading out. And so here is an early picture from the lander, and you can see those triangular flaps, and it gets a panoramic view, so you're actually seeing the whole spacecraft. You can see the deflated airbags, and actually you can see the rover a short distance away exploring that big rock that's nearby. And as you can see, where they landed Mars Pathfinder, there were a few more larger rocks, which was great because they really wanted to explore the variety of rocks on Mars with this mission. And very quickly, they started giving all these rocks fun names so that the various scientists planning out the mission would have something to refer to along the way. We've got names like Bam Bam and Indiana Jones and Zaphod and Scooby-Doo. And so the little rover, which is about the size of K9, had a big solar panel on top to keep it powered and a nice battery system inside. And of course, it's not getting any electricity from the sun during the night. So a lot of times it would kind of power down into a low power mode at night when it was colder. But I asked Jeff Landis, one of the project scientists, about this when I saw him at NASA in 2001 at a teacher conference I was at. He brought the Mars Pathfinder prototype with him. It was sitting on the table in front of us under glass. And I said, Mars is cold. How do you keep the batteries from freezing up? We have that problem in Minnesota. We have that problem in Alaska. And he said, well, what we do is we keep some of the motors running through the night with the battery power we have stored up and let the waste heat the batteries back up to keep them warm. And so it ends up being a loss game over time because that Martian dust is very thin and gets in all the little nooks and crannies. No matter how well sealed you think things are, that Martian dust finds its way in. And eventually you get a coating of Martian dust, not just on the solar panel, but under the glass in the solar panel, right on the photovoltaics. And eventually you get more dust and more dust accumulating, and that sunlight just doesn't reach the panel, and you don't have enough sunlight to store enough battery power to get through the night. And that's how Pathfinder eventually shut down. So there's again some pictures of the Pathfinder or the Sojourner rover taken by the Pathfinder spacecraft lander. And one of the cool things this thing had on it was its own little transmitter. It could transmit back to Earth with if need be, though it usually would transmit to the station, and the station would the lander, and the lander would send a much higher gain signal back. And it also had little tools. You could reach out and like core samples of the rock and run tests and so forth. Another thing to realize, a challenge with these rovers, is you can't just sit with a remote control and drive these things around. Okay, if you put a lander on the moon, it takes a second or so to get light to transmit to the moon and back. So any radio signal you're sending back and forth, there'd be a slight delay. That's why when you hear them talking to the astronauts on the Apollo missions, there'd be a slight delay in the conversation. That delay to Mars is about 20 minutes. So if you send a signal to Mars, it's about 20 minutes before the rover gets it. It's another 20 minutes before you get a signal back to know whether or not it received it. So what they had to do is kind of plan out the day and send a list of commands in advance. And the rover was built with some sensors that could help it avoid problems. It had collision sensors and things, so we could ignore the commands and come to a stop if there was a problem. Oh, you're trying to drive me over a cliff? I don't think so. I'm going to come to a stop. So this is pretty cool. Part of the reason we were able to do that is because computer technology is progressing at this point. All right, let's move on. So what did we do with this? We had the successful new landing system with Pathfinder. Pathfinder took more than 16,000 pictures and took more than 8.5 million measurements of atmospheric pressure, temperature, and wind speed along the way. Did a very detailed analysis of various nearby rocks, exploring composition and particle size of the Martian dust as well. The mission was expected to last 1 month and operated for almost 5. Fantastic. It was even commemorated in toy form. We had Micro Machines Mars Pathfinder toys. We had Lego Mars Pathfinder toys. This is a big deal. All right, well then, not long after, we had the Mars Surveyor mission, which was going to go into orbit in 1998, and it included a lander known as the Mars Polar Lander that was going to study the South Polar region of Mars. So this was launched at the beginning of January 1999, and in December, the lander was deployed and started to descend to Mars and didn't make it. Crashed into the surface pretty hard. We verified that later with the Mars Global Surveyor actually doing its mapping of Mars. We were able to actually see the crash site. There's been some stories that may be apocryphal that there may have been an issue with units when figuring out the last burn. When they're doing any sort of major rocket work with the spacecraft, the engineers at the rocket company, the engineers at NASA, go through a checklist with each other and verify everything before the burn to make sure that everybody has the right numbers. And The story I'd heard when I was younger was that one was talking in feet per second, one was talking in meters per second, and those units were not communicated. Don't know how much of that was true, but the rockets certainly had a problem during the descent and the spacecraft failed. So this is the one big US failure in terms of Mars landers. Now, we move forward a few years, and the British mounted a lander to Mars. They called it Beagle 2 after Charles Darwin's ship, the Beagle. This was part of the European Space Agency's Mars Express mission and was launched into space on a Russian Soyuz rocket. So we're getting a lot more cooperation between countries going on here. It was launched in June of 2003. The lander was successfully deployed from the Mars Express orbiter in December. It actually successfully landed in Cetus Planitia, not far from where the Perseverance rover is driving around today, on Christmas Day 2003, but unfortunately contact was lost. And eventually it was determined that 2 of the 4 solar panels did not deploy and blocked the communications antenna so that the lander could not talk to Earth. Couldn't get its commands to do what it needed to do, couldn't transmit back the data it found. Unfortunate. So the one British mission did not work. Now we go to a couple more successes. So we have a second generation of rovers following on the success of Mars Pathfinder called Spirit and Opportunity. They were launched a short time apart in mid-2003, arriving in early 2004. Both were planned to operate for at least 90 days, and both lasted several years. These are larger rovers than Mars Pathfinder with more instrumentation, able to do more, and able to drive at a little faster speed, so they're able to cover more ground. And as you can see, Warner Brothers kind of cooperated with them on the mission patch logos, with Marvin the Martian and Duck Dodgers being on the patches. The Spirit rover, as you can see, is a little bit bigger than Mars Pathfinder, with the head of the rover with its cameras up at full height. It's something like 5 feet tall, kind of wide, like someone in a large dress kind of poofing out. It launched in June of 2003, landed on January 4th, 2004 at the Gusev crater. And this is a little bit south of the equator and a few hundred kilometers from where the Curiosity later landed. And the plan was, again, a 90-day mission traveling about 600 meters. And the actual mission ran for more than 6 years and more than 7 kilometers. It eventually got stuck in some soft sand in 2009, but actually continued to operate for almost another year while stuck in the sand. It could no longer move, but it continued to take measurements from there and take photographs and so forth. And this is one of the early pictures after it landed, showing the kind of terrain it was going to be featuring. And again, you got a lot of that windswept Martian dust and a lot of rocks that turned out to be volcanic basalts on the most part. And then you can see some hills in the background which would later be explored by the rover. And again, Spirit explored many rocks that ended up looking like volcanic basalt on Earth, composed of many of the same minerals that we would see here on Earth. Geologists had a field day with this. We also were able to determine that local rocks do break down into the soil, although the high levels of nickel in the soil in places suggested that meteorites had also been broken down. There also was evidence that tiny amounts of water had altered some of the rocks over time. So again, some indirect evidence of liquid water having existed at some point on Mars. The dust is in this area. It turns out to be very chemically similar to the dust that had been measured elsewhere on Mars, and it is confirmed at this point to contain magnetite, which is basically iron rust, which is what gives it that color. And then we have the Opportunity rover, which was launched in July of 2003 and landed a few weeks after Spirit in the Meridian Planum. And Opportunity is actually several hundred miles away, kind of almost the other side of Mars, and kind of also just south of the equator. And again, it was planned to run for 90 days, and it actually ran for more than 14 years and drove 45 kilometers, explored several craters, including 2 large ones. And this is where that dust comes in again. It was actually lost during a planet-wide dust storm in June of 2018. The dust storm was raging for days and coating its solar panels, and it was into a hibernation mode and reporting in as it could. And it said good night one night, and we never heard from it again. This aerial photo of Mars kind of shows you the path that Opportunity took over those 14 years, starting near the Eagle crater, passing the Endurance crater, kind of skirting the Victoria crater, and then skirting part of the giant Endeavour crater. And if you're wondering why they didn't go down into the crater, those walls are kind of steep and you could end up losing the rover, having it tumble over itself. So it was better just to kind of drive along the edge and study what it could there. And if you see that blue outline on this picture, that is Washington, D.C. for scale. So this thing basically drove the perimeter of Washington, D.C. during its time. And to the right, you can see a selfie taken by Opportunity. Yeah, the Spirit and Opportunity rovers could take selfies. It wasn't just to be cute. They had an extendable camera that could take a selfie of the rover so they could examine damage. They could see how much dust was accumulating on the solar panel. They could examine damage to any of the 6 tires to determine why the spacecraft might be having trouble moving. But it did make for a lot of fun photographs for the press and on social media eventually. Okay, well, moving on. Opportunity actually saw a much wider range of rocks and regolith than Spirit did, and also found more evidence of past water activity on Mars, so that evidence is definitely building. It also found this rock known as the Heat Shield Rock, which was then confirmed by testing it as a meteorite. So this is a meteorite found on the surface of Mars by one of our spacecraft. All right. Well, after that, after 3 successful rovers, we actually landed another stationary lander on Mars. Stationary landers are cheaper to build, and so we can see more of the surface of Mars. But actually, part of the reason for this stationary one, I think, was to test where they were going to land the next rover. So in August 2007, the Phoenix lander was launched by the United States, landed in May of 2008 in Green Valley in Vestidas Borealis. This is, again, a little south of the equator. It's a few hundred kilometers away from where the Spirit lander had landed. And again, the plan was for a 90-day mission, and this one actually operated for 157 days. Mission wrapping up in August, but it continued to operate after that. Contact was lost in November as the solar power started dropping during the Martian winter. Same problem I described with the Mars Pathfinder. Eventually got too cold at night, and it didn't have enough power to keep the batteries heated, and they froze. And one of the great successes of the Phoenix lander was that those waters of Mars that we learned about in Doctor Who are frozen in a thin layer beneath the surface of Mars. And I apologize, the InSight lander is the one that was near Curiosity. This is the Phoenix lander. This was in the northern polar region. This is actually basically like an Alaska type territory. So yeah, you may know that the Martian polar cap is carbon dioxide, but there's water ice under the surface up there too. All right, now we go on to another great mission. This is the Curiosity rover. And there it is taking a selfie with its high-def camera. This was launched in late 2011, landed in 2012 in the Gale crater. And again, new landing system. Rather than the rover being part of the lander and the lander coming down to the surface and then the rover being deployed, the rover was strapped to the bottom of the lander, and the lander came down and then hovered like 30 or 50 feet above the ground and lowered the rover on what they called a sky crane. And then the rover was on the ground and ready to roll. And then the lander just flew a little distance away and landed. So cool thing. We get the rover immediately operational instead of having to wait a day or two to get it deployed. This was a 2-year mission plan, so would have wrapped up by 2014. Today is December 25th as I'm recording this, 2025. Curiosity is still working on Mars, exploring Mars, sending back data all these years later. Great success. It's done some exploration of Mount Sharp, which is the region where Spirit had landed. As of right now, in December of 2025, it has driven 36 kilometers from its landing site, 22 miles. It's basically driven across the Minneapolis-St. Paul metro in this time, or at least from 694 down to 494. This image here is of some of the project scientists or engineers with the prototypes for Mars Pathfinder, Spirit and Opportunity, and Curiosity, so you get a sense of scale. So where Pathfinder was the size, or Sojourner was the size of K9, Curiosity is about the size of an SUV. Much larger, able to cover more ground as a result, and a lot more instrumentation on board as well. So why do they build a prototype and then another one that they actually send that isn't that expensive? Well, first of all, they build the prototype to make sure that the whole concept's going to work. Second of all, they can use the prototype in the desert outside of Los Angeles to test the kind of maneuvers they plan the rover on Mars to do. The terrain is kind of similar out there. So they actually take the prototypes out into the desert and run tests and come up with the programming. All right, so here's some images taken by Curiosity of its surroundings. You notice these are a lot brighter. And that's because one thing we've been doing with the Curiosity mission is actually adjusting the contrast and brightness of some of the images to simulate what the rocks would look like if they had the same amount of sunlight that you would have on Earth. This makes it easier for the geologists working on the mission to examine these rocks in the pictures and kind of identify what kind of rock they might be before testing is even done. It really helps the geologists figure out the terrain. You can also see these cliffs in the lower image with the windswept erosion that look very similar to kinds of things we see in canyons on Earth. Was this done by water? Was it done by wind? This is one of those questions we're trying to solve with these missions, although wind is clearly a big component of the erosion on Mars today. There may have been water at some time. All right. Well, you could read up on what Curiosity's up to. There's a lot out in the press. Let's talk about one more mission from Russia and the European Space Agency from 2016. One last attempt, Schiaparelli EDM, named after a famous Italian astronomer, Schiaparelli. It's launched in March of 2016. The plan was for a 2 to 8 day mission to test technology for soft landings, for future missions, and to measure atmospheric electricity and local weather. Unfortunately, the lander did not work. During the landing in October of 2016, the parachute deployed too early, and so the spacecraft was coming down too fast and too hard and crashed into the surface. So apparently that test for soft landings did not work. All right, then we move on to the InSight lander, and this is the one, I'm sorry, it was actually the one that landed a little south of the equator, not the Phoenix lander, which was up north. So the InSight lander is kind of in the same region of Mars as the Curiosity rover and the Spirit rover, but obviously not in the same exact area. It launched in May of 2018. It is another stationary lander with very large solar panels to keep it operating. It landed in November in Elysium Planitia. The mission was to explore the deeper interior of Mars. And unfortunately, it did go into low power mode July 2022 and was lost in December of that year. So this was the first successful deployment of a seismometer. You may remember that Viking carried a seismometer. It wasn't able to actually get out onto the surface. InSight put a seismometer on another planet. It had a microphone to record sounds of the Martian winds. You can find these sounds online if you want to hear what Mars sounds like when the wind's blowing. In April of 2019, it recorded its first Mars quake, showing that there still is seismic activity on Mars. This is not unexpected, but it's also not necessarily expected. We know, based on the size of the volcanoes like Olympus Mons over on the other side of Mars in the Tharsis Plateau, that Mars does not seem to have active plate tectonics like the Earth. It doesn't have plates that move around. The volcanoes keep erupting in the same place. You don't get a chain of islands like you do with Hawaii on Earth. But there's still enough going on inside Mars that essentially earthquakes, Marsquakes, do happen. Another thing the InSight lander determined is that the magnetic field at the surface of Mars is actually about 10 times stronger than we thought it was. It's still not as strong as the Earth's by any means, so you don't get the protection from solar radiation and cosmic radiation that the Earth's Van Allen belts provide, because that Martian magnetic field pretty much sits at the surface rather than, thousands of miles out into space. But, we learned a little bit more about it, and yeah, Martian dust continued to be a problem. That is what killed this lander. It went into low power mode in 2018 because of all the dust accumulation, and eventually there was too much and not enough sunlight, and it stopped functioning. That image you see in the upper right includes an early picture of the lander it took of itself shortly after landing, and another picture it took of itself late in its life, where you can see it's just coated in that Martian dust. Okay, and then we come on to our other new friend, the Perseverance lander and the Perseverance rover and the Ingenuity helicopter. So this is a combination lander, rover, and helicopter. So just like with Curiosity, this spacecraft lowered a sky crane. So from the lander, it lowered the Perseverance rover to the surface so it could immediately start operating. And sitting on top of it was a small helicopter that we call Ingenuity. So it was launched in 2020 and it was delivered to the surface on February 18th, 2021 in Jezero Crater, which is an area we think might have been an ancient river delta, perhaps, if there had been running water on Mars at one time. This mission is still going on in 2025, 4 years on, almost 5 years on. So Perseverance has 4 main objectives. It is trying to identify past environments that could have supported microbial life. That's why it landed in what we think was a river delta. It's also trying, like Viking, to see if there are any signs of past microbial life, especially in certain rock types, because we know on Earth that certain types of minerals only form because of interaction with microbial life. And so looking for similar kinds of things on Mars. It's collecting rock and regolith samples and storing them inside the rover, thought being someday in the future, if we send a manned mission, we could collect those rocks and do something with them, bring them back to Earth somehow. It's also testing inside the spacecraft if you're able to take that carbon dioxide from the from the Martian atmosphere and create oxygen. This is thinking ahead to any future manned missions to Mars, trying to see what we can do to have an oxygen-producing facility for the astronauts. In the upper right, you can see a photo of the parachute taken from the rover as it was being lowered on the sky crane. As it was descending in the atmosphere, if you see there's a pattern woven into that parachute. And I'm actually wearing a t-shirt at the moment that has that same parachute on it. The scientists had a little bit of fun. The engineers had a little bit of fun. Encoded into that is a message. First of all, there are the GPS coordinates of the Jet Propulsion Laboratory in Pasadena, California, where the spacecraft was constructed. And it also has a Teddy Roosevelt quote, "Dare mighty things." And that's what this spacecraft is doing. It's daring mighty things. All right. Well, in addition to our rover that's driving around the surface of Mars, we had this tiny little helicopter on board with its own little solar panel and its special little rovers. Now, this was just a proof of concept. They wanted to see if they could fly a helicopter on another planet with a thinner atmosphere. The atmosphere of Mars is primarily made of carbon dioxide, but it is also about 1/1,000,000th the density of the Earth's atmosphere. So it's very thin. But if you have large enough blades or a large enough glider, you could conceivably fly. And this little drone was able to do 72 flights over a 3-year period. The plan was 3 flights in 45 days just to make sure we could make sure this worked. 72 flights in 3 years. Finally, one of the rotor blades broke off in 2024, and it landed, and the rover has driven away from it, and that last photo you see below is its goodbye photo as it drove away. But why did we do this? Not only to see if we could use helicopters to explore Mars or to get humans around on Mars someday. It allowed the helicopter to fly ahead of the rover and kind of scout the terrain that was ahead so that scientists back on Earth could make a different plan in terms of where the rover was going. Also, the thought is that we may want to explore the atmospheres of other moons or planets in the outer solar system, like the atmosphere of Titan. And so having a helicopter design that works on Mars might give us some ideas on how to build one that would actually operate on Titan. All right, and here is a picture on top taken by the lander of Perseverance there in the distance. And the lower picture is one of those selfies, I believe, of Perseverance with the helicopter Ingenuity landed slightly nearby. Now, another fun thing that our various landers have done is allowed us to photograph eclipses on Mars. So, on Earth, a solar eclipse happens when the moon passes in front of the sun, and it just so happens that the Earth's moon is large enough and at the right distance that it's, to our appearance, roughly the same size of the sun, so it covers the sun completely during an eclipse. Well, Mars's moons are much smaller. Phobos and Deimos are little asteroids it may have captured. And so when Phobos passes in front of the sun, it blocks out something like 40% of the sun, and Deimos it's even less. But the Opportunity rover in March of 2004 caught Phobos eclipsing the sun. You can see the image there. In 2013, you can see Curiosity was able to take a higher resolution black and white photo of Phobos doing the same thing. And our Perseverance rotor, using high definition color cameras, was actually able to capture eclipses of both Deimos and Phobos in 2024. All right. And finally, we've mostly been talking about successes by the United States, but China has successfully landed a rover on Mars as well. In 2020, they launched a Tianwen-1 mission to Mars, reached orbital insertion in February 2021. On May 14, 2021, it landed in Utopia Planitia, same general region as the Perseverance rover and where Beagle 2 was supposed to land. It's a very interesting mission. There were 6 components to it. There is an orbiter. There are 2 cameras it was able to deploy in orbit separate from the orbiter. And then there were 3 components that were sent to the Martian surface: a lander, a rover, and a deployable remote camera so it could take photos of the lander from a distance. Also, as we'll see in a picture in a moment, this one did not use the sky crane concept. The rover was mounted on the lander and just had a little ramp to drive down that deployed after landing. The Zhurong rover drove around for about 2 years and then was lost in contact in 2023 after it failed to wake from a scheduled hibernation mode, probably to ride out one of those cold winter nights. But here's China's success on its very first mission to Mars. And as you can see on the left there, the deployable remote camera took a nice photo of the rover and the lander together. And you can see that rover design looks a bit like the body of Spirit or Opportunity with the some of the instrumentation of Perseverance. Whether they just based the design on what they saw the Americans had done or somehow obtained data, we don't know. And picture on the right kind of shows the lander with the ramp extended, and you can kind of see some tracks in the soil from where the rover first drove down. Those are very high definition cameras taking good photos of Mars. And thing about the Chinese is they tend to hold their plans for missions very close to the chest. Don't tell us about them in advance, but trumpet the victories when they happen. So do they have another rover planned? Possibly. We have no idea. And that does take us on to the final discussion in a moment. But here's another photo taken from the Martian surface by the Zhurong rover. You can see it's a really high-def picture. And you can really see some nice like sand dunes of that Martian dust in front of us blown around by the wind. All right, so what's next? What's on the drawing board? I wish I had good news for you. There's several missions that have been on the drawing board in the United States for travel to Mars. But in the current political climate, there are a lot of cuts happening to science across the board. And whether or not any of these will ever come to pass, very good question. Similar problem in Russia. The Russians have several ideas that they've thrown around, but they've spent a lot of money invading Ukraine the last few years. And they don't have the money for science right now. They also had a problem a few months ago where one of the Soyuz rockets heading up to the International Space Station managed to damage their main launch pad at the Baikonur Cosmodrome, which is also going to slow down the manned space flight. So that's the bad news. The good news is Japan is pretty close to launching a mission to Mars. And so we may see that happen in 2026 if all goes well. There are also some plans on the drawing board in Finland and South Korea for a lot further down the road. So we may see some further Mars missions, but maybe not from the United States. The wonderful thing I have noticed with space missions in the last few years is that other countries have been getting involved. India has a rover on the lunar surface. One of the Middle Eastern countries, and I forget which one it was, put an orbiter around Mars in recent years. So we are seeing other countries starting to explore space, and hopefully we can all work together and share what we find. All right, well, there's a lot more I could say about each spacecraft, but I think I've given you a little taste of what we've been doing on Mars and who's been doing what and what's still going on. You can check in on Curiosity and Perseverance and what they're doing currently at NASA very easily. And Perseverance also has a pretty active social media presence. Hope you enjoyed this talk.